100 million Americans gearing up for our most dangerous winter storm in years.
160 million Americans
have dropped by double digits compared to yesterday.
No, this winter storm is making its way all across the country.
Unprecedented, potentially catastrophic storm.
Days, we've had 9 fatalities.
We have declared a state of emergency for Winter Storm Fern.
As of January of this year, Winter Storm Fern coated much of the United States in snow and ice. The massive storm knocked out power for over 1 million people and paralyzed travel across a dozen states. Freezing rain and heavy snowfall stretched from Texas in the deep south up through the mid-Atlantic. Thousands of flights were grounded and communities braced against days of dangerously low temperatures. It was a historic winter blast, the kind of bitter cold event that makes us wonder just how extreme winter can get. Yet, even a snowstorm this severe is just a cold snap compared to what Earth has experienced in the past. About 12,000 years ago, as the last ice age was ending, the climate pulled a sudden and dramatic U-turn. The world plunged back into a deep freeze in an event scientists called the Younger Dryas, one of the most striking and abrupt climate change episodes on record. This wasn't a fictional disaster or a movie plot. It really happened, and it happened fast. During the Younger Dryas, temperatures in the northern hemisphere dropped drastically. In a matter of decades, regions like North America and Europe were cooled by several degrees. In Greenland, the change was even more extreme. Ice cores show that temperatures there fell by as much as 10 degrees Celsius or 18 degrees Fahrenheit in just a few years. An almost instant return to glacial cold virtually overnight in geological terms. This climate whiplash left its mark on the natural world. The Younger Dryas period is actually named after a little Arctic wildflower, Dryas octopella, that flourishes in cold tundra conditions. Botanists find Dryas fossils abundantly in European sediments from this era. In other words, tundra plants suddenly spread south again, replacing forests with icy grasslands. It was as if the land itself signaled the chill. Life was suddenly forced to adapt to a new surge of cold. What could have caused such a shocking cold snap? The answer, scientists believe, lies in the oceans. In particular, a critical system of currents known as the Atlantic Meridional Overturning Circulation. Think of the AMOC as a giant ocean conveyor belt that transports heat. Warm water flows north from the tropics near the surface, and cold water flows back south deep below. As the great ice sheets of North America melted at the end of the Ice Age, massive glacial lakes formed. One of them, Lake Agassiz, held more water than all of the Great Lakes combined. Then, something triggered a sudden drainage of these lakes. An influx of fresh, cold water rushed out into the North Atlantic Ocean. This flooded off fresh water was like pulling the plug on an ocean conveyor. Normally, North Atlantic surface water becomes cold and salty enough to sink and drive the AMOC, but the meltwater was fresh and less dense, so the ocean water didn't sink as it should. In fact, the North Atlantic current shut down or slowed dramatically, no longer carrying warm water northward. Without that heat supply, the northern hemisphere rapidly cooled. It was a tipping point moment. The climate system flipped into a new state, and the deep freeze of the Younger Dryas was the result. Ice core records from Greenland and Antarctica reveal a telltale pattern. While the north plunged into cold, the southern hemisphere actually warmed up slightly at the same time. This bipolar seesaw, the north cold and the south warm, is exactly what we'd expect if the AMOC slowed down. With less heat carried north, the south held onto the more warmth, its remarkable fingerprint of an ocean-drive climate flip. In short, the Younger Dryas appears to have been a planet-wide chain reaction set off by that sudden gush of meltwater and the flattering of ocean currents. Deep freeze didn't last forever, but it did last a while. After roughly 1,200 years of bitter cold, the conditions that caused the disruption began to fade. The glaciers had retreated enough, and the monstrous flow of meltwater eventually eased. As the North Atlantic grew saltier again, ocean conveyor belt revived, and when it did, the climate snapped back dramatically. Greenland's ice cores showed that around 11,500 years ago, temperatures soared about 10 degrees Celsius, 18 degrees Fahrenheit in a decade or two, an astonishing warming almost as a shift in the initial cooling. Some areas may have been warmed even faster. In human terms, it was like an ice age turning off. In the span of the single generation, where there had been windswept, cold steppes, forests began to return. The Younger Dryas was over, and Earth entered the more stable climate of the Holocene, which we still live in today. But the abrupt way the Younger Dryas started and ended is a chilling reminder of how suddenly climate can shift. This ancient climate horror story carries a warning for the modern world. The Younger Dryas showed that if you push the climate system too far, big, abrupt changes can happen. Today, we are warming the atmosphere rapidly by burning fossil fuels, and scientists are watching the North Atlantic currents closely. There are signs that the AMOC has weakened in the recent decades. In fact, it's currently at its weakest point in over 1,000 years, according to some studies. As Greenland's ice melts and adds fresh water to the ocean, and as warmer temperatures make it harder for water to sink, the concern is that we might be nudging the AMOC toward another tipping point. Just like during the Younger Dryas, an influx of fresh water and warming oceans could slow down that great conveyor belt. No one expects an overnight ice age apocalypse. The situation today is not identical to the past, and the potential consequences, if it were to happen, sound like they pulled from a disaster script, except they're backed by scientific evidence. In short, it would be a lesser echo of that ancient freeze, still a serious crisis for modern civilization. Scientists stress that we absolutely want to avoid this scenario by reducing carbon emissions now before it's too late. In the end, the Younger Dryas stands as a cautionary tale from the ancient past. It shows that under pressure of change, the unthinkable can happen, and it changes us to make sure that history doesn't repeat itself in our future. The next chapter is in our hands, and with the knowledge and care, we can keep the most chilling twist of Earth's climate story where they belong, in the records of the past rather than the world of tomorrow.